बिस्मिल्लाहिर्रहमानिर्रहीम नहमदुहु व नुसल्ली अला मुहम्मद रसूलुल्लाहि करीम। ये प्रॉब्लम इंटीग्रल कैलकुलस, दिस प्रॉब्लम इज़ रिलेटेड टू इंटीग्रल कैलकुलस ऑफ chapter is double and multiple integration, so that in the reason D x greater than 0 and less than 1, y greater than 0 and less than x square, the following in double integration y upon x to the 5 plus 1 dA is equal to 1 upon 10 log 2. We are saying that this limit vary from x equal to 0 to 1 and x varies from 0 to 1 and y varies from 0 to x square. For finding the reason of D, we have to draw graph. We only region lie between 0 and 1. Between these two coordinate, this equation of y-axis, its equation is x equal to 0. This ordinate is distance from y-axis 1, so this is equation is x equal to 1. Now we find the value of y. Our strip will start from 0, y is equal to 0, adjust from x-axis, and because it lies between this, so this start between with this y is equal to 0, because it is x-axis, equation of x-axis y is equal to 0, and y is equal to x square. We know that y is equal to x square is a equation of parabola. We can write it as y square equal to y, compare with its standard equation of parabola, y square equal to 4ay. So it's we know that this equation, this parabola is equation is y square is equal to 4x, and if x square, here is x square, so this parabola is like this in positive side. This equation is x square is equal to 4ay, or x square is equal to y. So I write roughly this as it is about symmetrical about y-axis. So I draw it as, and reason of integration start from y is equal to 0 and ends with y is equal to x square. So we see that and we should confine in these two ordinate. So reason of integration is this. We can draw other strip. All strip start with y is equal to 0 and end with y is equal to x square. So reason of integration is only this, and limit of integration we can put by seeing this, and there is no need of draw this curve. So this value reason is D, we can write D, and this is reason D. You can find the required value of double integration y upon x to the power 5 plus 1. You have to prove it. So write the value of limit, because on right hand side we are given a constant value. So calculate it. Because x is constant, so write first x equal to 0 to 1, and then variable limit which is x square here and constant here, and write a function which is y upon x to the power 5 plus 1. I write dy first because I write this dy related to this, and we know that there are many writers which write here first dy here, then this relation to this, but I write dy for this integration and dx for this integration. So I integrate with respect to y first and then x. So for x, y is for y x is constant, so I take out 1 upon this value from this integration, and we can write it as x equal to 0 to 1 upon x to the power 5 upon x to the power 5 plus 1 take here, and integrate only remaining which is function y, and limit y is equal to 0 to x square, and integrate with respect to y. This will be function of x, and then we solve with this and integrate with respect to x. So we have to work here x equal to 0 to 1 and 1 upon x to the power 5 1 without any change, and integrate here is power 1, and on integration we get y square and power also upon same here upon in upon, and limit is y is equal to 0 to x square, and we have to integrate these values with respect to x. X equal to 0 to 1 1 upon x to the 5 plus 1, and now we write the upper limit in place of y. So I write x square in place of y, but here is y square, so I write y square upon 2 minus lower limit. We write y is equal to 0 here, and square it upon 2. Write here upper limit minus lower limit, we get this value. 0 to 1 upon x to the power 5 plus 1, on opening this bracket, this multiplied, then we get x to the power 4 upon 2 minus this value 0 upon 2 is 0, we have to integrate only this value 0 to 1 x to the power 4 upon 2 and x to the power 5 plus 1 dx. If we consider for integration, we should use a substitution, putting x to the power 5 plus 1 is equal to t. On differentiating, we get 5 x to the power 4, and dx differentiation of 1 is equal to 0, and differentiation of t is equal to dt. If we want this value x to the power 4 dx, so divide 5 whole equation, we get x to the power 4 dx is equal to, we can take 1 here, 1 upon 5 dt. So this integral is equal to this, we write here double integration y upon x to the power 5 plus 1 d is equal to, take 2 outside from integration by writing 1 upon 2, because 2 is in denominator, so 1 by 2 is take out from there, and we have to only integrate function, but the limit is 10 because variable is 10. I write this value is t in denominator, so I write t here, and this value is becomes 1 by 5 dt. So I write x over 4 dx 1 by 5 dx. But limit is changed. It is not limit of t. We have to check it. Because the relation is given, we can find the value of t easily by putting the value of x here. For lower limit, for x is equal to 0, we put the x is equal to 0 here. 0 power 4 plus 1, 0 power 4 is 0, therefore lower limit t is equal to 1. For upper limit, I put x equal to lower limit in relation this, and find the value of t by putting the value of x in this expression, and find the value of t which is equal to 1, which is lower limit 1. So I write t is equal to 1 here, and to find the upper limit we have to put the 1, x equal to 1 here. So for x is equal to 2, we have to find value of t by this relation, x to the power 5 plus 1 for x equal to 1, x is equal to 1, which is upper limit here. So put x equal to 1 here. 1 to the 5 plus 1, 1 to the 5 is equal to 1, 1 plus 1 is equal to 2, so I write 2, which is upper limit. Now we have to integrate you can take 1 upon 5 outside break integration, so only we have to integrate 1 to 2, 1 upon t dt. We know that integration of 1 upon t is equal to log t. Here 1 into 1 1, or 2 into 5 10, and integration of 1 upon t is log t, and limit is 1 to 2. On you have apply upper limit first. You put t is equal to 2, upper limit minus lower limit. You can find a lower limit by putting the value of t here, log in place of t, and value of t is 1, because log 1 is equal to 0, therefore log 2 1 upon 10 log 2. Here base is not I write it is known, this base is e. We have to prove this integration is 1 by 10 log 2, which was to be proved. Thank you very much indeed for listening me. Wa akhru dawana alhamdulillahi rabbil alamin.